The orbits of Earth and Venus are approximately circular, with the Sun at the center. From Earth, a line of sight to Venus and the line of sight to the Sun make an angle of 15 degrees. Real briefly, let's talk about what's happening here. If blue is the Earth and the green dots are Venus, there's only one Venus, but Venus can be in two possible places. If yellow is the Sun, from Earth we see Venus, and that makes an angle of 15 degrees with the line of sight to the Sun. So we've got 15 degrees here. Well, we would have that same angle whether or not Venus were a little bit closer to us or a little bit farther from us. In those two spots we would get that same angle. So this question is asking, what are these two distances? So the short line or the long line, what are the two distances or the possible distances from Earth to Venus? Now we're given the radius of Venus's orbit and the radius of Earth's orbit as well. Venus's orbit has that radius of 1.085 times 10 to the 8th kilometers. This purple line. And yes, we will have a line as well right here, because like we said, Venus could be a little bit farther or a little bit closer. We'll talk about this closer situation in just a minute, but first let's talk about this farther distance. Okay, so what we've got is this large triangle, and I'm just going to draw it down here just a little bit bigger. It looks a little bit like this. And you've got this 1.805 and 15 degrees still. And what we want to find is this distance now. I'll call it d sub 1 between Venus and Earth. So I'll just kind of relabel that. We've got Sun in the center. Okay. This distance from the Earth to the Sun is the 1.495 times 10 to the 8th. Oops. Okay, kilometers. So, how do we find this? Well, first we have to find this angle right here. And we can find that using the law of sines. That is, the sine of 15 degrees divided by the side length that is opposite that, and that's this 1.085 times 10 to the 8th. Is going to equal sine of this angle here. I'm going to call it beta sub 1. Because we'll have a beta sub 2 for this smaller triangle, over the 1.495 times 10 to the 8th. Solving for a sine of beta sub 1, that equals approximately 0.3566. And taking the inverse sine of this number, beta sub 1, then gives you 20.9 degrees, rounding to the nearest tenth of a degree. Okay, beta sub 1 is 20.9 degrees. We have that here. So now we can proceed to solve for d sub 1. Well, first I have to find this. We'll label this angle gamma sub 1. This angle between Venus and the Earth from the Sun's point of view. And that's gamma sub 1 is simply 180 degrees minus the 20.9 from one part of the triangle minus the 15 degrees from another vertex of the triangle equals then gamma sub 1 would be 144.1 degrees. Okay, that's our gamma sub 1. Let's underline those. Now let's use law of sines to find d sub 1. So we have sine of 15 degrees over the 1.085 times 10 to the 8th equals sine of the gamma that we just found. That's the opposite of the distance that we want. So sine of 144.1 degrees over d sub 1. What is this distance? Okay, solving for that. D sub 1 gives us 2.460 times 10 to the 8th kilometers. So that's one of the possible distances of Earth to Venus. What's another possible distance? I'm going to change colors here and try to fit this in here. We've got another triangle, and now that this is already here, I'm just going to draw right over that. This is our other possible triangle. So I'll draw that down here. There, and we still have this angle as 15 degrees, and we still have, we found out beta sub 1, but now beta sub 2, the other possible angle, right, where this was beta sub 1, up here was beta sub 1, this would be beta sub 2. We'll label that there. Beta sub 1, beta sub 2, the two possible angles for the two possible triangles. All right, so beta sub 2, well, that's going to be 180 degrees minus beta sub 1. So just let's write that down. Beta sub 2 is 180 degrees minus beta sub 1. So minus the 20.9, and that is going to equal 159.1 degrees, which then gives us gamma sub 2, this final angle, 180 degrees minus the 159.1 minus the 15 gives us 5, let me fit that in there, 5.9 degrees. 5.9 degrees. Okay, now we can use what we know to solve this d sub 2. Let me label that d sub 2. The other possible distance from Earth to Venus. And it's going to be, this d sub 2 is opposite of this gamma angle, opposite of 5.9 degrees. So again, I'm going to say that sine of 15 degrees divided by that opposite distance, which is 1.085 times 10 to the 8th, that will equal sine of 5.9 degrees divided by d sub 2. So solving for d sub 2, we then get approximately 4.309. Let's move that down. D sub 2 equals approximately 4.309 times 10 to the 7th kilometers. So either a little bit closer or a little bit farther from Earth. So that's an application of astronomy using the law of sines, and we had the ambiguous case of the triangle there.